In this video, we are going to find integers x and y such that x squared plus x equals y to the power 4 plus y cubed plus y squared plus y. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. There is a very simple trick that can help us solve this equation very quickly, which is to multiply both sides by 4 and add both sides by 1. So by doing that, the left side would equal to 4x squared plus 4x plus 1. And the right side will become 4y to the power 4 plus 4y cubed plus 4y squared plus 4y plus 1. Now, the left side equals 2x plus 1 all squared. So in fact, we're actually doing completing the squares, and at the same time, the right side, the expression at the right side is very close to some other perfect squares. One example would be 2y squared plus y all squared, which equals 4y to the power 4 plus 4y cubed plus y squared. The red and the blue expressions have the power 4 and the cube terms exactly the same, and their difference is 3y squared plus 4y plus 1. And in fact, that equals to 3y plus 1 times y plus 1. And such a difference is positive for the most of the time when y is less than minus 1 or y is larger than minus 1 over 3. And since y is an integer, we're given that y is an integer, that's equivalent to integers y that are at most minus 2, and we have to omit minus 1 because minus 1 does not fall within this range. But starting from 0, all the integers count. So that means we're actually talking about this difference being positive for all integers except minus 1. So for most of the time, our expression at the right is always for most of the time is larger than 2y squared plus y all squared. And for the exception, when y equals minus 1, the difference is exactly 0. So it's fine because when y is minus 1, then we know it's a perfect squared, and the left side is also perfect squared, so there is a high chance that we can find some solution when y equals minus 1. But we're going to leave that for another time. On the other hand, this expression is also pretty close to 2y squared plus y plus 1 all squared, which equals to 4y to the power 4 plus 4y cubed plus 5y squared plus 2y plus 1. Now the difference between this perfect squared, which is just the consecutive perfect squared with 2y squared plus y all squared, has a difference to be y squared, so as to say minus y squared plus 2y plus 0. The constant term are the same this time. There are only two different terms. And for this difference, the red minus the blue can be factorized as minus y times y minus 2. And in fact, for this expression, again, it will be positive when y is between 0 and 2. So in fact, that's equivalent to only when y equals 1. Of course, it will be 0 when y equals to 0 or y equals 2. And for all other cases, that will be negative, which is that the expression that we have at the right is smaller, in most occasions, smaller than 2y squared plus y plus 1 all squared. and that's when y less than 0, negative integers, or y is at least 3. So combining these two cases, these two ranges that actually covers almost all integers, the only special cases are when y equals -1, 0, 1, or 2. And for the other cases, so these are special. Otherwise, we will have 2y squared plus y all squared is strictly smaller than 4y to the power 4 plus 4y cubed plus 4y squared plus 4y plus 1, and that's also strictly smaller than 2y squared plus y plus 1 all squared. And from this relation, since we must have the expression in the middle to be also perfect squared, it's impossible for perfect squared to be between two consecutive perfect squares. So for those so-called otherwise cases, we have no solution. So all the solution comes from our special cases when y equals -1, 0, 1, or 2. Now we can try that one by one. When y equals -1, then x squared plus x, going back to our original equation, would equal to 0, and same when y equals 0. And so x equals -1 or 0. So we have 4 solutions. Four solution pairs on the numbers -1 and 0. Now when y equals 1, x squared plus x equals 4, clearly no solution. And finally, when y equals 2, x squared plus x equals 30, and we have x equals -6 or x equals 5. So we have 2 more solution pairs, which are 5, 2, and -6, 2. So these 6 pairs, 4 up there and the 2 in the middle, are our final answers. Please feel free to share ideas in the comments. Thank you for watching. See you next time.